Hello everyone, today we would like to present project management plan on the topic real-time water level monitoring early warning system for the Bang Khun Chien agriculture area. Start with the project context. Bang Khun Chien is the only area in Bangkok that adjacent to the sea, and farmers face severe flooding that caused significant economic damage. Therefore, we conceived the idea of creating the warning system. The reason this project requires project management principles are: first, it involves developing a prototype to solve specific local problems. Second, there is a clear time frame for the project to build and deliver system upon successful delivery. The project is terminated and transition to routine maintenance. Third is cost functioning involving engineering, hydrology, and legal aspect. For setting objective, we use the SMART rule. S stands for specific to create a prototype water level alert device using an ultrasonic sensor. M stands for measurable. It must able to send alert quickly and accurately. A stands for achievable. It is feasible because we are using existing technology such as ESP32 and NB-IoT network. R stands for relevant. It addresses the economic problem of the community. T stands for time-bound. This project must be delivered by August 2029. To ensure the project effectiveness is quantitative, we have set 4 key performance indicators. First, economic productivity must be maintained at least 85%. Second, system latency must ensure alerts are issued within 1 minute. Third, the system will trigger when water levels are 1.5 times the average. Fourth, we anticipate that successful flood prevention will contribute to 12% annual economic growth. To prevent scope creep or the scope of work spiraling out of control, we have clearly defined an explicit scope statement. What is within the scope includes installing sensor in Bang Khun Tien. What is within the scope includes installing sensor in Bang Khun Tien canal, system integration, and sending notification via Line API. What is outside the scope and will not be done in this project includes scaling up to cover Bangkok, developing new mobile application, or controlling floodgate.
This page illustrates our work breakdown structure, which serves as the foundation of the project. We have categorized the work into 6 main pillars: system design, project management, public relations, development, and and budget allocation. Each pillar is broken down into specific work package and subtype to ensure every technical and administrative requirement is accounted for. Okay, for the next page. To execute the work breakdown structure, we have established this organization breakdown structure. The project is led by the project director and deputy project director. We have specialized roles such as the system architect and full stack developer for software, while the field technician and hardware engineer handle the physical implementation. This ensures clear accountability for every task. Our timeline is divided into 4 quarters. This is our timeline that show in the chart. We have the phase that focus on the initiation, planning, and system design, phase of development and testing, and the final phase that deployment, prototype installation, and system demonstration. Okay, for the next page is about the logistic tree. The first logistic tree is legislative. The legislative process begins with identifying national water resource laws. We then review infrastructure policy to summarize compliance requirements. These lead to mapping stakeholder and obtaining the necessary installation permit to ensure the project is fully authorized. Okay, for the next one is the system design logistic 3. Our design phase integrates both hardware and software requirement. We start with through requirement analysis to draft the architecture design. These include specifying hardware components and creating simulation to finalize the blueprint before development begins. For the next one is budget allocation 3. For the budget allocation, we look beyond just expenditure. We as labor costs and employee welfare to ensure team stability. Most importantly, we conduct a return of investment analysis to identify measurable benefits and the payback period for the stakeholder. The next one is development logistics 3. Technical this is the technical core. We program the water level sensors and configure microcontroller to process data via custom algorithms. This data is integrated into an online platform featuring an alert notification system designed for high accessibility for local users. For the next slide is project management logistics 3. In management, we prioritize quality assurance or QA by monitoring communication reliability and validating software. We maintain rigorous documentation standard, achieving version history and calibration logs to support the future maintenance and system scalability. For the last logistic 3 is about the public relation logistic 3. Finally, our PR strategy focus on the localization by engaging community leaders. We coordinate with the government for sponsorship and use press management to launch public awareness campaigns. This ensures the community is prepared and knows how to respond to early warning.
So once we have already discussed about time constraint management, now we will talk about a budget constraint management. Obviously, the budget for our project is the full 2 full years or 735 days, and the total budget we have calculated so far is totaling at 144,850 baht, in which the budget per modules we have discussed will be costing roughly 25,000 Thai baht in total. But that is just the upper limits for each modules. We also have a power supply and housing, which costs around 2,500. For microprocessor and sensor hardware, each one will cost around 1,000 Thai baht. And the communication modules which send feedback to the server. For our labor, we're gonna have the labor outsourced from the external organization. They're gonna take care of our project, which costs around 5,300 baht per module. Apart from our project is the stakeholders. Stakeholders will consist of an internal stakeholders and the external stakeholders. One of the most prominent stakeholders we have listed so far are 4 of these entities. First one is the project directors and the board of executive. When we're gonna have an independent strategy to deal with each stakeholders, which is to either collaborative or report regularly to each stakeholders. And for the latter two, municipal authorities disaster prevention office and the financial sponsor. These are the external stakeholders, in which we have to actively engage, stay informed of their updates, and try to satisfy their requirement in our project. Now we have a risk that we have identified so far that will comprise of the negative risk, or so-called threats, and the positive risk, which is the opportunities. Two of the most major threats are the requirement change from the user. If there is a sudden change that can be detrimental to our project, like, so we're gonna have someone responsible for that task. That is the project directors. We're gonna have to re-estimate time and budget, aka re-baseline that things. And for the threats that could occur incomplete system specification. In this case, electrical or electronics engineer will be accountable for that. We could create a small prototype or CADs for testing. And apart from the threats that we have mentioned so far, there are also opportunities. Opportunities are the early government sponsorship, in which if the government contract us early, we can just capitalize on that by presenting it to them in the first quarter. And last thing for our project is the assessment. How do we assess this stuff is to perform a phase gate reviews. That is comprised of sensor accuracy testing, statistical analysis, and whatever satisfy our stakeholders and user. And when do we assess that? We're gonna have to trace back to our Gantt chart, in which we're gonna have to assess this project periodically at the end of the procedure, aka when the green node in the logistic tree is reached. And how do we tell that this task or this project is complete? Well, if all of the target in the 6 green nodes of the logistic tree are met, we will call that complete. But complete doesn't mean successful. And how to tell if it is successful is that the project must be when all the KPIs of our project are reached, such as the system feedbacks and 1 minute interval. And furthermore, that must contribute to 12% in economic growth. So in summary, our project will be designing a 1 minute advanced warning system. We could design CADs before we perform the real implementation. That's to protect 85% of the economic value of the regions under the constraint of 9,650 baht per point under the time frame of 2 years. So what tool did we use to perform this project management analysis? The scope and planning. We clearly define this in the work breakdown structure and the organization breakdown structures. For time management, we have utilized the Gantt charts to identify discrepancies in our workflows. Furthermore, our projects also have a stakeholder in charge, so we have to analyze the stakeholder individually. And there's also a power interest matrix in the appendix if you want to look at the full scale analysis of the stakeholders. And finally, once the project is finished, we're gonna have to assess it. As I have mentioned earlier, we're gonna have to perform a phase gate framework criteria to control the quality and measure its success. And that's all for the presentation. Feel free to give us feedback on our project. Thank you very much, Professor.